Assalamu alaikum everyone, let's start the stream once again. This is the O-level mathematics paper that we'll be solving today. It's a mathematics syllabus D paper 4024, paper 2, variant 1, and it's summer 2024. So let's start solving this. This is a calculator paper, so let's just get our calculators out. Here we go. The cost of a ticket, the first question as you can see on the screen is that the cost of a ticket to watch a basketball match is 67.60. The cost of one ticket is $67.6. The total money received from ticket sales for one match is 1180. So the total number for all of the tickets is 1183000 dollars. So if this is the total cost, they're asking us to find the number of tickets sold. Well, the number of tickets sold will obviously be the total cost divided by the cost of one ticket. So that we can find out the total number of tickets sold. So the total cost is 1183000 upon the cost for one ticket, which is $67.6. So now we can just use a calculator to evaluate this. So 1183000 divided by 67.6. Now this comes out to be 17500. This is the number of tickets that we have that are sold for this match. Let me just check if the stream is going as it should be going. Yep, perfect. Next question that we have is that the cost of one ticket at 67.60 is 4% more than the cost of one ticket last year. Yes, 4% more than the cost of one ticket last year. So this cost is 104% of a certain value of last year. Why do I say 104? Because, well, whatever the value X was of last year, the value would be at its 100%, and then we would add an additional 4% because it's 4% more, right? It's 4% more than the cost last year, which we're labeling as X. So this is the value and the percentage that we basically set up, and we need to solve for X because we want to find the cost of one ticket last year. So let's just multiply by 100 on both sides to get 6760, and let's divide by 104 on both sides. 6760 divided by 104 comes out to be 65, and that is the answer for the cost of one ticket last year. Next question that we have is that the number of seats in the basketball stadium, is 20545. So 20,545. The number of seats sold for the first match of the season is 19,340. So the number of seats sold, this is the total number of seats and this is the number of seats sold. It is 19,340. So now they're asking us to find the percentage of seats in the stadium that are sold. Well, the percentage of anything is basically the number of cases that actually are fulfilled upon the total number of cases. So in this case, we have 19,340 seats and there are total 20,545 seats. In order to find the percentage, since percentage basically means multiplied by 100 or per 100, so we basically multiplied this by 100. Now, let's just use a calculator to evaluate this once again. Multiplied by 100, and we get the percentage 94.134, which you can basically write the three significant figures as 94.1%. The next question that we're asked is that team plays 41 matches. The total number of matches that they played is 41. They're also saying for the 41 matches, the mean number of seats sold per match for 44 matches, mean per 41 is 16,440. This is the number of seats that are sold per match on an average. And they're also telling us that the total number of seats sold for the first 21 matches is 329,000. Now this is the total and this is the mean. So what they're trying to get us to do is basically they want us to calculate the mean number of seats sold per match for the last 20 matches. So they're asking us the mean number over here. But we don't know the mean if we don't know the total number of seats in the last 20 matches. So how can we do that? Well, see, the mean of anything is basically the total over how many cases that we went over. So basically the sum of all of them upon the number of cases that we had. So if we're talking about here, this case of matches and the mean number of seats per match, the mean number of seats is 16,440. This is equal to the total number of seats in 41, total number in 41 upon the total, basically the number of matches, which was 41. So to find the total number of seats in 41 matches, we find that it was total number in 41 was 16,440 multiplied by 41. So this is the number of seats that we had in this amount of matches. So that is about 674040 seats. This is the total number of seats in the 41 matches. Now in order to find the number of seats that we had in the last 20 matches, we subtract the total number of seats in 21 matches from this. So 674040 minus 3296000. And this is the number of seats that we have now in 20 matches. 345040 seats. Now, in order to find the mean number of seats sold in the last 20 matches, we divide this by 20 so that we can get the average of it. So, dividing by 20, we get that the mean was 17252 seats in the last 20 matches. So, that's that. Let's move on to the next question. We have the salaries of 3 basketball players. So, we have the salaries of 3 basketball players and we need to find the difference between the salaries of 2 of them, Tristan and Stephen. The salary of Tristan is 3.64 times 10 to the power 7, while the salary of Stephen is 8.27 times 10 to the power 6. So the difference basically means we'll subtract these two values, so 3.64 times 10 to the power 7 minus 8.27 times 10 to the power 6. So what we can do in order to make this easier for us, instead of going on full calculator mode and evaluating these and expanding these, we can basically rewrite 3.64 times 10 to the power 7 by moving one 10 away from this. So this becomes 3.64 times 10 to the power 6 minus 8.27 times 10 to the power 6. Now you might be wondering why we did that. What we'll do is basically we'll evaluate this part of it. So it becomes 36.4 times 10 to the power 6 minus 8.27 times 10 to the power 6. And since there are both 10 to the power 6 over here, we can take that common. It becomes 36.4 minus 8.27. Now when we evaluate that with the calculator, 36.4 minus 8.27, that becomes 28.13 multiplied by 10 to the power 6. Now we can move this decimal place one point further and it becomes 2.81 multiplied by 10 to the power 7. That is the difference between the salaries of Tristan and Stephen. The next question we are given is that the total Joe earns is a salary plus a bonus of X dollars. The total he earns is 102.5% of his salary. So first his total is equals to his salary plus bonus of X dollars. And they're also saying the total he earns is 102.5% of his salary. So total is equals to 102.5 upon 100 multiplied by his salary. And what is his salary? Well, we can see that from the table. Joe's salary is 4.29 times 10 to the power 6. So let's find out the monetary value of the total and then subtract the salary from it to find X. So 102.5 divided by 100 multiplied by 4.29 times 10 to the power 6. It becomes $439,7250. This is the total, and they're also asking us to subtract. This is the total, and we're adding the salary with X to find that total. So in order to find X, what we'll basically do is subtract the salary from it. The salary of Joe is 4.29 times 10 to the power 6. So let's just subtract that. 4.29 times 10 to the power 6. 4397250 minus 4.29 times 10 to the power 6. Now, this is about 107,250, and that is the value of X. We can write this in standard form if we want to, but I think this will do for now. The next question is one of a scatter diagram. So let's just check that out. Okay, so they've given us a scatter diagram and they've told us to plot the last few points. So what we'll do is basically just take the height on the x-axis and the temperature on the y-axis and plot it as so. They've already plotted the first 5 points for us, so we can plot the rest of them. The second question that they're asking us is describe the type of correlation shown in the scatter diagram. Well, as you can see, all the points are heading downwards. They're going on a trend like this, right? That means that it's a negative correlation because it's going downwards. So the correlation that we have here is negative. The next question that they've asked is to draw a line of best fit on the scatter diagram. So what we'll do is we'll join a line that roughly joins the points. It does not need to go through every single point, but it just goes through enough points and there must be the same number of points above and below the line. So like so. This would be a sort of example scatter line. Best fit line. The next question that they ask is that another reading is taken as a height of 1000 meters, and we need to use our line of best fit to estimate the temperature at this height. So what we'll do is on the x-axis that we have the height, right? So we'll go on 1000 and then go to our line of best fit. Wherever 1000 will intersect with our line of best fit will be the temperature that we will take as answer. The answer key basically says that this temperature can be around 7.88 to 7.884. Let's move on now. The next question is that they're given the time taken by 80 adults to climb the mountain. And I think this is going to be an estimate of the mean time and histogram question. So let's just solve that. So here we have, they've given us the times taken by 80 adults to climb the mountain. They've given us two columns, time and frequency. Now what we need to do is calculate an estimate of the mean time. In group data, mean data is always calculated as summation of fx upon summation of f, where f is the frequency and x is basically the point, or the x value or time taken, or whatever is being measured, whatever's frequency is being measured. So first thing to do is to find out what we need to multiply. Make the columns of f and x already for us. So f we have 8, 15, 20, 23 and 14 from the table. But what about x? X they've given us as a range, and we can't take it as a range because we don't know which one to multiply with which. So what we'll do is basically find out the midpoint of these. 5.5 plus 6.5 divided by 2 is 6. That's the midpoint of those two. 6.5 and 7.5's midpoint is 7. 7.5 and 8 is 7.75. 8 and 8.5 is 8.25. 8.5 and 10.5's average is 9.5. So now we have the values of f and x. We'll just find fx now. So what we'll basically do is multiply both of these. 15 times 7 is 105. 20 times 7.75 is 155. 23 times 8.25 is 189.75. And 14 times 9.5 is 133. So now we have all of these values. What we're going to do is basically add it up, because summation means that we need to add up all of the fx's, right? So let's do that. 133 plus 189.75 plus 155 plus 105 plus 48. We get a total value of 630.75. And what do we need to divide it by? Summation of f. Summation of f, they've already given us that there are times taken by 80 adults. We can add them up once again, but it will obviously be 80. So in order to find the mean, let's just divide them by each other. So 630.75 divided by 80 is simply 7.88. Now the next question they've given us is that a histogram is drawn to show this information. The height of the bar representing 5.5 to 6.5 is 8 millimeters. Now they want us to find the height of the bar representing 8 to 8.5. The simpler way to basically find this out is what we can do is we can see the frequency representing 5.5 to 6.5. From 5.5 to 6.5, the frequency, which is basically the height, is, let me check from the graph, 8. And that is being represented by 8 millimeters. However, what we need to keep in mind here is that 5.5 to 6.5 is not being represented entirely by its frequency. It's being represented by its class width. So first we need to calculate the frequency density of it, and then we need to apply that to that. So first let's find out the frequency density in a histogram of 5.5 to 6.5. We would have frequency upon class width, which is 8 upon 1, and that would just be 8 again. So 8 is being represented by 8 millimeters, which means that 1 of class width, 1 of frequency density is being represented by 1 millimeter. In the case of 8 to 8.5, we see that the frequency that we have is 23, while the class width is 0.5. That means it's frequency density of 46. If 46 frequency density exists and one frequency density corresponds to 1 millimeter, then that obviously means that 46 frequency density would calculate to 46 millimeters. So that is our answer. The next question is that we've been given a diagram of a triangle and they were asking us to find angle PQR. This is the triangle that we're being shown with an isosceles triangle over here and an angle of 142 degrees over here. This is PQR. So what we need to do is first realize that this is an isosceles triangle. This must mean that its two base angles, this angle and this angle, are equal. Because the arrows over here are pointing to these two angles, so they will be equal to each other. Now, another thing that we have here is that since this is equal and we're already provided an angle over here, we can easily find out this angle because angles on a straight line are all equal to 180. So 180 minus 142 is equal to 38 degrees. 38 degrees is present here, and since this is an isosceles triangle, this would be the same. They're asking us to find angle PQR, and we already have two angles in this triangle, so obviously we can find it out because the sum of a triangle's angles is 180. So 180 minus 2 times 38 is equals to angle PQR. So 180 minus 2 times 38 is equal to 104 degrees. And that is the answer. Let's move on to the next question. We're given this set of triangles and we need to prove that they are similar to each other. The triangles look like so. And these two are parallel lines. We need to prove that triangle ABE is similar to triangle CDE. Well, the first thing that we have is these are vertically opposite angles, so they will obviously be equal to each other. The second thing we have is these two are parallel lines, so these angles will also be equal to each other, and when all three angles of two triangles are equal to each other, then that means those triangles are similar. The next question we have is that two of the factors of 50 are square numbers. And they're saying that one of the square numbers is 1. So one of the factors of 50, that is a square number, is 1. What is the other factor? Well, we can go and test this because the next few square numbers are 4, 9, 16 and 25, and we already know that 25 is a factor of 50. 25 2s are 50. So the other square number that is a factor of 50 is 25. The next question, we've been given a few numbers a and b as a product of their prime factors where x and y are positive integers. So they've given us in terms of x and y. Let me zoom in on this question. The questions that basically digits that we have over here are 2x to the power of 2 to the power of x minus 1 times 3 to the power of 2y times 7, 2 to the power of x plus 3, 3 to the power of y, and 5. They're asking us to find the HCF of a and b in terms of x and y. So the HCF of any two numbers is basically the lowest common factors that they have. For a and b, they have 2 and 3 in common. So let's just pick out the lowest of those, the lowest powers in these. So x plus 3 and x minus 1, obviously x minus 1 is the lowest of these. So 2 to the power of x minus 1 comes first. And then 3 to the power of 2y and 3 to the power of y. Obviously 3 to the power of y is less and it is the lowest of the common factors that they have. So 3 to the power of 5, y would be our answer. 5 and 7 we will not consider because they're not common. Next question, they're asking us to find the LCM of these two same numbers in terms of x and y. So the simple thing for LCM is that we need to choose the highest numbers out of them, meaning the ones with the highest powers. And they do not need to be common, they just need to be present in either one of them. So the first thing we have here is 2. For 2, the highest power that we have is x plus 3. For y, 3, we have the highest power of 3 to the power of 2y. For 5, we have 5 to the power of 1, and 7, we have 7 to the power of 1. We consider 5 and 7 because this is the LCM, and we need to basically check out every single number that is present in either of those A and B. So that is our answer. Let's move on to the next question. We have question number 5 over here. We will be solving half of this paper in today's stream and half of the paper in tomorrow's stream. So the question that we have is that two companies move boxes. Company A charges $0.5 for each box plus a fixed fee of $125. So what company A basically does, 0.5 multiplied by the number of boxes, which I'm going to call B over here, and we add a fixed fee of $125. Company B, however, only charges a fixed fee of $350. So find the number of boxes moved when company A charges the same as company B. This must mean that their total cost is the same, right? So this is the total cost of A and this is the total cost of B. And we need to find the number of boxes moved. So we'll basically be solving for B. So if they're the same, then that means 0.5 B plus 125 is equal to 350. Subtract 125 on both sides to get 350 minus 125, which is equal to 225. And divide that by 0.5 on both sides to get 450. So 450 boxes need to be moved in order for this to be equal. Let's move on now. Now, they've given us an upper bound, lower bound questions. Let's solve it. The maximum mass a van can carry is exactly 770 grams, kg. 770 kg. And they're saying that the van carries boxes of 4 kg each, correct to the nearest kilogram. So if we just correct to the nearest kilogram, that means that it's 1 kg that it's correct to. And that means that the error that we will be having, since that is the accuracy, the error will be half of the accuracy, which is 0.5 kg. So this will be the amount that can be added or subtracted into this the number of boxes that we have. They're asking us the upper bound of the number of boxes that this van can carry. This means that it must be 770 divided by a certain number of boxes. Now, the mass of that boxes, I mean. So if we're finding the mass of the number of boxes, we would need the lowest number of to be in the denominator for this to be the greatest, right? We need to find upper bound in the answer. That means that the mass of the boxes must be as low as possible. So the mass of the boxes, in order to get it as low as possible, will take its lower bound, which is 4 minus 0.5, which is 3.5. So let's just divide it 770 by 3.5 in order to find the upper bound of the lower number of boxes. 770 divided by 3.5 is 220 boxes. The upper bound of the number of boxes that can be carried by the struct is 220. The next question that we have is the lorry contains a boxes of 3 sizes S, M and L. Let's just write the headings here because it's a ratio question. They're saying that the ratio of the number of boxes to 2 to 7 is SM. So 2 is to 7 and SM. And we're saying that the ratio of S to L is 5 to 4. So S to L is 5 to 4. And they're saying that the total number of boxes of size L is 72. So they're saying that the number of boxes of size L is 72. Well, first let's move from ratio to reality. If there are 4 in the ratio and we need to make it to, what is the factor that basically brings us ratio to the real life? 70 divided by 4 is basically multiplied by 18. That means that the number of boxes of S here must also be multiplied by 18. That means that it's 90. The number of boxes in S is 90, the number of boxes in L is 72, but we cannot do the same with this because these are not to the same ratio as S and L are. So what we can do is basically bring this to the same ratio. In order to make 2 into 5, we basically multiply by 2.5, and the same thing we'll do with 7. So 7 multiplied by 2.5 would give us 17.5, and this will multiply by 18 and we get 315 boxes. So 315 boxes of M are contained, and they're asking us to find the total number of boxes in the lorry. So what we'll do is we'll just add all of these up. This is 477 boxes, and that is the total number of boxes in the lorry. The next question is one of transformation. They're saying that triangle A is mapped onto triangle T by translation of 1 minus 3, and we need to draw triangle P. Well, since they've already given us triangle A, what we basically need to do is basically move all of the x coordinates of triangle P one up, and the y coordinates of triangle P 3 to the 3 bottom, 3 down. 3 downwards and 1 is to be moved upwards. In that way, we'll find the coordinates of triangle P and we can draw it on the graph. And they're asking us to describe fully the single transformation that maps triangle A onto B. Well, the first thing I should notice is that there are different sizes. If there are different sizes, there cannot be any of the 3 other non-isometric isometric transformations. It must be enlargement. If it's enlargement, in this case it's retardation, but in the same way we can find the scale factor. The scale factor would be minus 1 upon 2. Since the shape is also inverted, it would be enlargement, and we can find easily the center of enlargement by joining the lines of all of those 3 points. The last question is one of a reflection and rotation question. First, we would need to apply the reflection along that line, and then we would rotate it about 1, 1 in order to find that triangle Q, and then you can draw it easily. The last page, we are here to the last page of this series, and then we'll be solving the rest tomorrow. 7a. A cuboid has dimensions 5 centimeter by 12 centimeter by 8 centimeter. So dimensions are 5 by 12 by h, and its volume is 480 centimeters. So volume is 480 centimeter cube. So the volume of anything, of a cuboid specifically, is all of its sides multiplied by each other, LBH. So it's 5 times 12 times h is equals to 480. This becomes 60. H is equals to 480, and h is obviously 4 with this. So h is 4 centimeters. In the next question, we're given a basic geometrical question. Let's just try and solve it. B. ABCDE is given as a pentagon. AE is parallel to BD, and AE is equal to 21 centimeters. BD is 16 centimeters. They've given us a lot of angles. We need to find angle BAE. Well, the first thing to notice over here is that, well, let's just draw a scale diagram of this trapezium thingy first. 16 degrees, 65 degrees. This is 90. Since this is parallel, this will also be 90. We need to find this angle BAE. Well, the first thing that we notice is that if we extend this line, it will be something like this. I've drawn it a bit crooked, but it will be something like this. And that means that this angle will be 65 degrees. But since this will also be a straight line, the angle over here will be 180 minus 65. And this will be 115. That's pretty much all for today, and we'll continue this tomorrow. Sorry for the hesitation and glitching. My internet is not working well these days. So yeah, that's pretty much all for today. See you all tomorrow.